The use of high computational power to solve complex calculations at high speed is called high-performance computing, or HPC. Traditionally, this is done on supercomputers or clusters. However, the cloud is an attractive alternative. Clouds offer a lot of computing resources on demand, often without waiting times, on a pay-per-hour basis. But cloud HPC also comes with new challenges. Currently, Amazon EC2 offers 637 different instance types. It is difficult for users to figure out which hardware configuration to choose. Users want the results of their HPC jobs as quickly as possible, but also do not want to pay for hardware they don't need. The best choice depends on the application, but also on the parameter values of the individual job. For users without specialized computer engineering knowledge, finding the best option for a specific job is almost impossible. They need help. This is why we at TU Delft developed the AI Resource Recommender, AIRR. AIRR helps small labs and individual users optimize their choice of cloud resources for their HPC application. Other resource recommenders rely on extensive modeling, training data, or search processes. AIRR does not need any of that. It simply relies on user-submitted jobs that need to be processed anyway. The only thing that users need to do to make AIRR work is submit their own HPC jobs. That's it. The user only ever sees the front end, but will notice that jobs execute faster and costs become lower over time. AIRR casts the problem of resource recommendation as a contextual multi-armed bandit problem. As a user submits an HPC job, AIRR recommends a cloud instance type. After execution, the user collects the results they need and can use those in the way they intended. Meanwhile, the system creates a fingerprint of the job and its behavior and saves it in a database. At first, AIRR simply explores. As more jobs come in, it uses the LinUSB algorithm to explore the different options. But as the system gathers more and more fingerprints, it uses those to train a neural network to model the application's behavior with different inputs and hardware combinations. AIRR balances exploration and exploitation. The first few recommendation choices are aimed at exploring the behavior of the application. They are not necessarily optimal from the user's point of view. However, as AIRR gets a grasp of the application's behavior, it switches to exploitation. It exploits the information it gathered in the earlier phases, and its recommendation choices become better and better. The algorithm ensures that the overhead costs that come with exploration remain as low as possible. AIRR can be used for a wide range of HPC applications, so it is suitable for use in small labs or companies. But AIRR can also be attractive for cloud providers. As AIRR recommends optimal choices of hardware configurations for specific jobs, it can help cloud providers better utilize their infrastructure. At this stage, an extended user or customer base is essential for delivering further improvements and refinements of the tool. For now, our industrial partner, InAccel, has taken a close look at AIRR, confirmed our evaluation results, and came to the conclusion that AIRR is ready for wider adoption and commercial use. We hope that in the future, industrial as well as non-profit parties will recognize the gains that AIRR can deliver.